In October 2025, every telescope on Earth went blind. 3-Eye Atlas, the third confirmed interstellar object in human history, slipped behind the sun and vanished. What followed was not silence born of mystery, but of pure geometry. For weeks, no Earth-based or Earth-orbiting instrument could see past the sun's glare. Then China quietly broke the blackout. Without announcement or press briefing, the China National Space Administration uploaded a set of images from its Tianwen-1 Mars orbiter. The world had been waiting for any glimpse of 3-Eye Atlas after perihelion. These were the first post-flyby images, and they were nothing like what scientists expected. Instead of answers, they raised urgent questions about cosmic violence, geopolitical secrecy, and whether our models are far more fragile than we believed. A discovery wrapped in urgency, 3-Eye Atlas was first detected on July 1, 2025 by a survey telescope in Chile. Its hyperbolic orbit confirmed an interstellar origin. Within days, observatories worldwide aimed every available instrument at it. Hubble, JWST, and dozens of ground telescopes scraped together spectra, light curves, and shape estimates as the visitor sped toward the sun. But by October 3rd, it had reached a position impossible to observe from Earth. The blackout wasn't technological, it was orbital fate. Every telescope went blind at once. NASA and ESA's last published images ended abruptly on the edge of this window. Forums exploded with speculation. The question echoed everywhere. What was happening on the far side of the sun? The only eyes still watching. While Earth was blind, only a handful of spacecraft near Mars still had a clear line of sight. But NASA's Mars probes, ESA's Mars Express, and India's Mangalyaan all went silent about their observations. Only one probe acted, China's Tianwen-1. The orbiter was never built for comet tracking. Its cameras were designed to map Martian dunes and clouds, not a faint, fast-moving interstellar object. But mission engineer Zhang Li pushed the spacecraft beyond its intended limits. Tracking routines were rewritten, exposure settings recalibrated. The Mars Climate Imager was driven to maximum sensitivity. The medium-resolution camera took rapid bursts so engineers could stack and enhance the faint signal. Within days, a set of processed images appeared quietly in the CNSA data archive. No press release. No explanation. Just timestamps, metadata, and the first glimpse of 3-Eye Atlas after its disappearance. If the Tianwen-1 frames are accurate, then 3-Eye Atlas may have undergone catastrophic fragmentation faster and more dramatically than any known interstellar object. That would mean our understanding of interstellar material strength is flawed. Solar weather interactions are more destructive than predicted. Orbital solutions for such bodies are far less stable. Future interstellar visitors may be even harder to track or interpret, as one physicist summarized. If this data holds, we just watched an interstellar body collapse under our own star's breath. Now the world waits. NASA, ESA, ISRO, and Roscosmos are racing to release their own post-perihelion data. Until they do, Tianwen-1's images remain the only window and the only spark for a mystery growing by the day. 3-Eye Atlas may be natural. It may be fragmented. It may be something we don't yet have a framework to describe. But one truth cuts through the uncertainty. Where transparency falters, mystery thrives. And tonight, the unknown has the upper hand. Scientists expected a comet-like body. What they saw instead defied all categories. 1. A violently lopsided coma instead of the smooth, symmetric halo expected of cometary bodies. The coma was torn, stretched, and uneven, almost shredded on one side. 2. Debris arcs and splinter-like trails. Curving arcs and streaks drifted along its orbit. Analysts ruled out instrument artifacts. The trails were wider than star point spread functions and behaved like real structures. The green glow now layered. A mysterious emerald tint previously seen before perihelion returned, but this time it appeared in rippling layers, like the object was shedding plasma-rich material in uneven bursts. 4. Brightness flares with no natural explanation. Brief spikes of light erupted along the direction of motion. They repeated, not randomly, not as cosmic ray hit something more organized. Taken together, these images painted a disturbing picture. Three-Eye Atlas was changing, violently, toward a crisis of explanation. Using optical proxies, researchers estimated plasma activity far exceeding anything seen during the famous 2015 cnsa hit on Comet 67P. The torn coma and flare spikes suggested an event of staggering energy, but the anomalies didn't fit neatly into any model. A cnsa had swept past Mars days before, but its power couldn't fully account for the rhythmic flare pattern or the extreme gradients. Thermal stress could shatter the nucleus, releasing arcs of debris. Yet scientists found no clear non-gravitational acceleration, something expected if fragmentation were severe. Some streaks could be starfield distortions, but the widest debris features remained inconsistent with any instrument effect. Only mentioned because the flares appeared rhythmic, but no periodicity reached statistical confidence and no propulsion-like accelerations were detected. Every explanation was incomplete. Nothing fit comfortable. China's immediate release of the images triggered a philosophical divide within the scientific community. Some praised the openness China published so the world could judge for itself. Others defended NASA and ESA, better to be right late than wrong fast. But for weeks, the Chinese dataset was the only dataset. Amateur and professional astronomers validated what they could: starfield alignment, metadata consistency, probe orientation, and found no signs of manipulation. Still, without independent calibration from other Mars missions, the images remain both trusted and limited.